Okay, so we're talking about percent yield. So this is going to deal with the theoretical, so basically what we've been talking about. So we have a yield, so a reaction. I begin the reaction with 32 grams of C2H6. So I have to start with my normal theoretical yield, so my normal stoichiometry question. So I'm going to start with C2H6, and I want to see, after this combustion reaction, because you have O2, CO2, and H2O, how we're going to get to our total of grams of CO2. So CO2 is going to be 12 plus 32, so we get 44 for every 1 mole of CO2. Remember, this is going to be another 3-step problem. So I have 12 times 2 is 24 plus 6, so I'm going to have 30 grams of C2H6 for every 1 mole of C2H6 as well. So we're still, nothing's changing really. We're just still getting to the amount that we have. So I need to see or get rid of this. So this is where my molar ratio comes in. Again, C2H6. So that's going to get rid of these. We can already get rid of our grams. And now we want to get rid of our 4, because we see 4 moles of C2CO2. So that's moles. So that way we can get rid of this and this. So we can find our math to figure out what our theoretical yield is. So we are going to have 32 divided by 30 times 4 divided by 2 times 44. So that will give us, nicely enough, we have a total of 0.9, sorry, grams of CO2. So this, let me fix this, 93.9 grams of CO2. So this is our theoretical yield. Okay? Now, what we're going to do is we're going to figure out our percent yield. So it says, what is the percent yield of 44 grams if this is our theoretical? So this is what we got. So we're supposed to put 44 grams of CO2 over our theoretical, which is 93 grams of CO2. So remember, it's always actual over theoretical times 100 to get our percentage. Okay, so in this case, we take our 44, we're going to divide it by 93.9, and that gives us a percentage of 46.9% accuracy. So in other words, we had something wrong because we weren't very accurate at all. All right, now let's go ahead and try it again. So I have a new equation. So I begin the reaction with 80 grams of Cl2. So I have my 80 grams Cl2, and I have to get to grams of carbon chloride. So CCl4. So remember, that's going to be 1 mole of CCl4. And carbon, so you have chlorine, that's 35.5 times 4, which is going to give me 142, plus 12 is going to give me 154 for my molar mass of carbon tetrachloride, sorry. And then I can figure out, so chloride is going to be 71 grams for Cl2 for every 1 mole of Cl2, get rid of my grams, and now I can cancel it out. So I see that for every 3 moles of Cl2, I have 1 mole of carbon tetrachloride. So I can get rid of my moles on all the abounds, and then I can start doing my math. So I take my 80 divided by my 71, divided again by 3, and then multiply it by 154. Oh, that's wrong. No, that's right. So I had an answer of 57.8 grams of carbon tetrachloride. So it looks like we're going to have a little bit better answer last time than we did this time. So if we actually produce, remember, actual over theoretical, so we take our 38 grams over our 57.8 grams. So 38 divided by 57.8 gives us an answer of 65.7%. So it's still better, but not the best. All right. So just remember that that's how we are going to do. We're still doing our stoichiometry, still finding our yield, but now we're basing it off of what we actually do versus the theoretical. So seeing how accurate we were with our reaction. All right. Any questions? Please ask.